My presentation is on Project Loon, a moonshot project by Google. And what the goal of Project Loon as an overview is they want to give internet to remote areas around the world through a network of balloons. And they have the building blocks of a cell tower, which we'll get into the hardware of that. And the balloons are launched in the stratosphere where they're able to stay up for a longer period of time due to weather conditions, usually 100 days, but the long run goal for Google is to far exceed that. So how is the balloon move is a question, and it uses the winds in the stratosphere to move around the Earth and to certain areas that need the internet. So another question would be is how to redirect the balloons, and you're capable of doing this by within the balloon. The larger balloon is a smaller balloon, and that smaller balloon inflates or deflates. So for example, just see here is if you inflate the balloon, it will move up, and it will move up into another wind stream where it can then be relocated to where that balloon is needed to give internet service. And then Google's able to do this, or Project Loon is able to do this by predicting wind forecasts. So here we have a far out picture, and we have the troposphere, and then in the stratosphere. The stratosphere is where you are going to find the balloons moving around in, usually within 18 kilometers to 23 kilometers. They travel above, any wildlife, any commercial jetliners. It's a safer location for them, and the balloons have hardware in them so they can communicate with air traffic control. So if you look in the lower bottom portion of the screen, in the right you'll see a gray building, and then you'll see some users, and on the next slide we'll get into that. And how is internet transmitted? Well, if you look here, this lower gray building that I was talking about is a telecommunication provider, and Google has contracts or links up with this provider, and a wireless internet signal is transmitted to the closest balloon. So it would be this balloon in this picture, and it transmits the wireless signal to this balloon, and this balloon transmits the signal to that balloon, and then it's transmitted down to the end user. So you're going to end up having a network of balloons communicating with each other. And as this balloon moves out, if it's still in range, it will communicate with that other balloon, and this balloon will move to fill the gap as to that balloon left, and they'll still communicate with each other. And the balloons can only communicate with other balloons if they're about 100 kilometers, which is about 62 miles within each other, and they'll able to transmit data between each other. So it just shows the network and how it works. So also, a balloon can give service to an area of 50,000 square kilometers. So usually it serves about thousands of people. So to put that in perspective, we have Rhode Island here. And Rhode Island is approximately 1,045 square miles of land area. So a balloon covers 50,000 square kilometers, and if you convert that roughly, it's about 1,931 square miles. So therefore, a single balloon could potentially provide service to all of Rhode Island. Okay, so what is this technology? What is the hardware, and how does it work and run? Well, here we have, the balloon, the larger balloon, and then down at the bottom is the hardware that we're going to be talking about. So this right here is the flight capsule. The flight capsule is the brains of the system. It allows for the control of the balloon, like moving it up into wind streams or into different wind streams. It contains sensors for recording weather conditions, which will help with finding the right paths to move the balloon throughout the Earth. And then it has GPS, to locate it, and for air traffic control. And there's batteries in it, which we'll get into for a moment what those are used for. this right here is solar panels. So, power during the day, and it charges the batteries on board for use at night. And then what we have right here in the bottom is the parachute, which is for when the balloon comes back down to safely land it. And then it's going to show up on the bottom left and the bottom right. We have transceivers, and these allow for transmission from, the ground telecommunication providers and between balloons and with users on the ground. So, something to think about with all of this is the thought of, will Project Loon succeed? In an obstacle to consider when you think about this is you're going to have a balloon that provides internet with no borders. Potentially, it's gonna fly all over in the stratosphere to different countries. Like, they've already done tests in New Zealand, so it could be over India and stuff, and that could cause potential political problems. Having different kind of aircraft flying over in this, airspace is going to come with regulations and government approval. So there's potential problem for that. As Kevin Fitchard mentions, most governments consider the stratosphere above them their sovereign airspace, which is why they shoot down spy planes that venture into it. So the long-term goal for Project Loon is to let these balloons kind of go about on their own and give internet where needed. So to do this is going to require a lot of negotiating with other governments and everything to make sure this is okay and to meet up to the regulations and everything. And then also another thing to take away from this is that their goal is to provide internet to all these remote locations where you normally want to get internet. And it's a really good thing, but it's also about profits. You have to think that Google is going to be, in a sense, a worldwide internet service provider, and they'll be, the internet's not going to be free, and they'll be selling it, or they'll be making contracts with other internet providers on the ground to sell internet. So that's just something to consider, and that's the end of my slideshow.